Bir Hakeim, Libyan Desert, 127 kilometers southwest of Tobruk, June 3, 1942, 05:45 hours. And Obergefreiter Klaus Steiner of the 15th Panzer Division stood motionless behind his sand-covered observation post, binoculars trembling in his dust-caked hands as he watched what no German tactical manual had prepared him for. American Army engineers transforming barren desert into a fully operational military airfield in 72 hours, moving more earth in 3 days than the entire Afrika Korps engineering battalion had moved in 3 months, using machines so massive and numerous they seemed to materialize from American industrial mythology rather than actual manufacturing capacity. And in that crystallizing moment of absolute clarity, Steiner understood with the certainty of mathematical proof that Germany had not merely underestimated American capability, but had fundamentally miscalculated the nature of modern industrial warfare itself, that victory or defeat would not be determined by tactical brilliance or ideological commitment or even battlefield courage, but by the raw productive capacity to conjure airfields from sand, to manufacture bulldozers by the hundreds, to deploy engineering equipment in such overwhelming abundance that impossible became routine, ordinary, expected. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The site had been empty desert 48 hours ago. Steiner had personally conducted reconnaissance of this exact grid coordinate on June 1st, filing a report that described nothing but rock-strewn wasteland, scattered acacia bushes, terrain utterly unsuitable for military operations. And yet here, on the morning of June 3rd, stood a completed airfield. Graded runway stretching 1,800 meters, taxiways connecting to dispersal areas, fuel storage bladders already positioned, communications equipment erected, defensive positions dug and fortified, and most impossibly, American transport aircraft already landing, their tires finding purchase on desert that had been impassable wilderness 72 hours prior. Steiner had been fighting in North Africa since February 1941, had witnessed Rommel's mastery of mobile warfare, had participated in the lightning advances that captured Benghazi, Tobruk, El Aghelela, had absorbed the foundational belief that German tactical excellence and operational innovation would overcome British material advantages, that the Afrika Korps' lean efficiency would triumph over enemy logistical excess. But nothing in 16 months of desert combat had suggested that any army could build airfields faster than German forces could maneuver to prevent their construction. The American Engineering Battalion, identified through careful observation as the 809th Aviation Engineer Battalion based on shoulder patches visible through his binoculars, had arrived at the site on the afternoon of June 1st in a convoy that stretched beyond the horizon, a mechanized column so extensive that Steiner had initially assumed he was witnessing a major offensive preparation, but the Americans had not deployed for combat, they had deployed for construction, and the distinction between these two activities seemed to not exist in American military doctrine, where engineering battalions arrived with the combat power of armored divisions, where construction equipment moved with the speed and coordination of tank formations, where building became as aggressive and decisive as attacking. The convoy had included machines Steiner had never encountered in European theaters. Bulldozers whose blades could move cubic meters of earth with each pass, scrapers that loaded and transported dirt in single integrated operations, graders that created smooth surfaces where moments before had been broken ground, compactors that transformed loose sand into load-bearing runways, and most remarkably, all of this equipment functioned in desert conditions that destroyed German machinery within weeks. American machines operating through dust storms and heat that would have required complete maintenance for German equivalents. Hauptmann Friedrich Weber, Steiner's company commander and a veteran of the Polish and French campaigns who had earned an Iron Cross First Class at Sedan, had joined him at the observation post at 600 hours, bringing coffee and field bread. And the two men had watched in silence as American engineers completed the final runway markings, Weber finally speaking only to note that the Americans were finishing an airfield in the time it would take German engineers to complete the initial survey work, that what they were witnessing represented not superior technique, but superior industrial capacity, that Germany could not defeat an enemy who manufactured construction equipment with the same abundance that the Reich manufactured rifles. And his voice had carried not anger or frustration, but a hollow recognition that the fundamental assumptions underlying German strategy were invalid, that all the tactical victories in North Africa were meaningless against an opponent who could create air bases from nothing in 3 days. The engineering sequence itself had followed a pattern that suggested extensive standardization and rehearsal, beginning with survey teams who marked the runway alignment with stakes and flags within the first hour of arrival, followed immediately by bulldozers that began rough grading, cutting through the desert surface to create a level foundation, working in coordinated teams of 6 machines operating in parallel lines, the blade operators displaying a precision that would have been impressive in peacetime training exercises, but seemed almost impossible under combat conditions in hostile territory. By nightfall of June 1st, the rough runway alignment had been completed, a strip of graded earth stretching 1,800 meters through terrain that German maps had marked as impassable to wheeled vehicles. And the Americans had worked through the darkness, their equipment illuminated by generator-powered floodlights that turned night into day, an electrical display that would have drawn Luftwaffe bombers if the Luftwaffe had possessed sufficient aircraft in theater, but by mid-1942, German air superiority in North Africa had eroded to the point where American engineers could work with impunity under lights visible for 30 kilometers.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. June 2nd had brought the detail work, scrapers moving thousands of cubic meters of material to create the precise elevations required for drainage, graders creating the exact surface specifications needed for aircraft operations, compactors ensuring the runway could support the weight of fully loaded bombers. And throughout the day, American engineers maintained a pace that would have required German units to work triple shifts. Yet the Americans seemed to operate on standard 8-hour rotations, achieving in normal working hours which should have required round-the-clock emergency efforts. And Steiner had begun to understand that American engineering capacity existed at a fundamentally different scale than German equivalents, that what seemed like superhuman effort was actually routine American industrial output. The Americans had deployed pierced steel planking, a technology Steiner had heard referenced in intelligence briefings but never witnessed in operation. Interlocking metal sheets that could be laid directly onto prepared ground to create an instant runway surface. And watching American engineers position these panels with mechanical precision, connecting them with built-in clasps that required no welding or bolting, creating a continuous metal surface that could support aircraft within hours rather than the weeks required for concrete runways, Steiner had recognized that Germany faced an opponent who had fundamentally reimagined military engineering, who had industrialized construction in ways that eliminated traditional limitations. The equipment itself contradicted everything Steiner had been taught about mechanized warfare in desert environments. German doctrine emphasized light, maintainable vehicles that could function with limited logistics, accepting reduced capability in exchange for operational sustainability. But the Americans had deployed massive machines that seemed to ignore logistical constraints entirely. Bulldozers weighing 15 tons moving through sand that would have immobilized German half-tracks, scrapers with enclosed operator cabins protecting against dust that disabled German engines. And all of this equipment functioned without the constant mechanical failures that plagued Afrika Korps vehicles, suggesting either superior engineering or maintenance infrastructure so robust it became invisible. Steiner had observed American mechanics performing routine maintenance on their equipment during work breaks, and even this mundane activity revealed capability gaps. The Americans had spare parts inventory that exceeded entire unit allocations, specialized tools for every maintenance task where German mechanics improvised with general-purpose equipment. And most tellingly, the maintenance technicians worked with casual confidence rather than the desperate improvisation that characterized German field repairs. By the afternoon of June 2nd, the runway surface had been completed, the pierced steel planking creating a distinctive metallic appearance that reflected sunlight across the desert, and American engineers had immediately begun constructing taxiways, dispersal areas, revetments for aircraft protection, demonstrating that the runway itself was merely the foundation for a complete airbase infrastructure that would be operational within the 72-hour timeline. Support facilities appeared with the same mechanized efficiency. Fuel storage bladders positioned and connected to distribution systems. Communications equipment erected and tested. Defensive positions dug at perimeter locations. Water storage tanks installed, all coordinated through a command structure that seemed to anticipate every requirement without the delays and confusion that characterized German construction projects. The Americans worked with extensive written documentation. Engineers constantly referencing technical manuals and specification sheets, suggesting standardized procedures that eliminated improvisation. And Steiner had recognized that American engineering battalions could probably build identical airfields anywhere in the world because they followed documented processes rather than relying on individual expertise. The American command post, identifiable by its antenna arrays and constant vehicle traffic, had been established in a natural depression 400 meters from the runway, and throughout the construction period, Steiner had observed a steady flow of officers arriving for briefings, their vehicles moving with the same efficient purpose as the engineering equipment. No wasted motion, no confusion, just systematic execution of a plan that had clearly been developed and rehearsed before the battalion arrived in theater. The American commander, identified through binoculars as a lieutenant colonel based on his insignia, moved through the construction site multiple times per day, inspecting work, consulting subordinate officers, examining completed sections with what appeared to be quality control checklists. And his presence suggested an emphasis on supervision and standards that contrasted with German engineering practices where officers typically remained at command posts directing work through radio communications. June 3rd, before dawn, had brought the final preparations. Runway marking teams painting numbers and directional indicators. Engineers testing the surface load-bearing capacity by driving heavy trucks across completed sections. Communications personnel establishing radio contact with arriving aircraft. And at 0530 hours, just 70 hours after the first American vehicle had arrived at the empty desert site, Steiner had watched through binoculars as a C-47 transport aircraft approached from the north, circled once to verify runway alignment, and landed smoothly on the pierced steel surface, its tires finding solid purchase where 3 days earlier had been loose sand and broken rock. The aircraft had taxied to a dispersal area, shut down its engines, and within minutes ground crew had begun unloading supplies, transforming the completed airfield from engineering achievement into operational military asset. And in that transition, Steiner had witnessed the ultimate purpose of American engineering speed, not merely to build quickly, but to establish operational capability faster than opponents could react, to create military infrastructure that enabled the next phase of operations before defenders could organize effective responses. Additional aircraft had followed throughout the morning, a steady stream of transports and fighters landing at 15-minute intervals. Each successful landing demonstrating the airfield's functionality, proving that American engineers had not merely created the appearance of an airbase, but had built genuine operational infrastructure to exact specifications in impossible timeframes. By 0700 hours, a dozen aircraft occupied the dispersal areas, their presence attracting American anti-aircraft units who arrived in convoy and immediately established defensive positions around the perimeter, and Steiner had recognized the integrated nature of American military operations, where engineering battalions, aviation units, and air defense forces coordinated seamlessly to transform empty desert into defended airbase in 3 days, a combined arms capability that the Afrika Korps could not match even with its vaunted tactical flexibility. Obergefreiter Hans Richter, from the 33rd Reconnaissance Battalion had arrived at Steiner's observation post mid-morning, bringing water and updated intelligence reports, and the two men had shared brief conversation about what they were witnessing. Richter noting that his unit had observed similar American construction projects near Benghazi and Derna, that this was not an isolated example, but represented standard American engineering capability, that reconnaissance elements across the Afrika Korps area of operations were reporting identical construction timelines at multiple locations, suggesting that American aviation engineers could create airfield networks faster than German forces could maneuver to interdict them, fundamentally altering the operational calculus that had governed North African warfare for 2 years. Richter had served in France and had witnessed the permanent air bases there, concrete runways and hangars built over months or years, and he struggled to reconcile those experiences with what American engineers accomplished in 3 days. The disconnect between European and African theaters revealing that American capability had expanded dramatically between 1940 and 1942, that the industrial base supporting American military operations had achieved production levels that Germany could not match and probably could not even measure. The fuel delivery system alone justified detailed observation. American engineers had laid temporary pipeline from their supply base to fuel storage bladders positioned near the runway, eliminating the jerry can transfers that characterized German refueling operations, and watching American ground crew refuel a P-40 fighter in under 10 minutes using direct pump connection, compared to the 30-minute manual refueling required for German aircraft. Steiner had recognized that American engineering extended beyond construction to encompass every aspect of airbase operations, that their systematic approach eliminated inefficiencies throughout their operational chain, achieving speed advantages that compounded across thousands of individual tasks. The Americans had even installed basic repair facilities, portable maintenance hangars with comprehensive tool sets, suggesting they planned for the airfield to support sustained operations rather than serving as temporary forward base. And this long-term perspective contrasted sharply with German engineering in North Africa, which focused on immediate tactical needs rather than infrastructure development. Hauptmann Weber had returned to the observation post at noon, bringing disturbing news from division headquarters. Reconnaissance had identified 6 additional American airfield construction projects within 200 kilometers, all following identical timelines, all utilizing the same equipment and techniques, all progressing toward completion within 72-hour windows, and the cumulative effect of these simultaneous projects meant that American air forces would soon operate from distributed airbase networks that provided redundancy and flexibility impossible to neutralize through conventional counter-air operations. Weber had received orders to prepare detailed reports on American construction methods, and he had asked Steiner to document everything observed over the past 3 days, recognizing that tactical intelligence about this particular airfield mattered less than strategic understanding of American engineering capability that would reshape the entire North African campaign. That Rommel and his staff needed to comprehend the industrial capacity they faced, that tactical brilliance could not overcome an opponent who manufactured air bases faster than armies could advance. The American defensive perimeter had expanded throughout June 3rd, engineers working with infantry to establish fortified positions at intervals around the airbase, creating integrated defense that protected against ground attack while the runway continued receiving aircraft. And this simultaneous attention to construction and security demonstrated organizational capacity that impressed Steiner, despite his growing recognition of its implications for German prospects. The Americans deployed in-strength sufficient to defend against company-sized attacks, their defensive positions incorporating machine gun nests, mortar pits, communication trenches,
all constructed with the same methodical efficiency that characterized the runway construction. And watching American infantry dig fighting positions with mechanical equipment rather than hand tools, creating in hours what would require German infantry days to construct manually, Steiner had understood that American mechanization extended beyond obvious applications to encompass tasks that other armies performed with manual labor, that their equipment abundance allowed mechanization of operations that seemed too minor to justify specialized machinery. By mid-afternoon, the airbase had achieved what appeared to be full operational status, with continuous aircraft movements, refueling operations, maintenance activities, all occurring with coordination that suggested extensive training and standardization. And Steiner had drafted his initial report for Hauptmann Weber, attempting to capture in military terminology what seemed to defy conventional military analysis, trying to explain that American engineers had accomplished something that changed fundamental assumptions about campaign timelines and operational possibilities, that airfield construction could no longer be assumed to require weeks or months when American battalions completed functional airbases in 3 days, that German mobile warfare doctrine had been predicated on movement speeds that no longer provided operational advantage when opponents could create supporting infrastructure faster than armies could advance. His report emphasized the equipment quantities, noting that the single American engineering battalion had deployed more heavy machinery than the entire Panzer Army Africa possessed, that their bulldozers alone represented industrial output equivalent to German tank production for several months, that defeating such an opponent required either matching their industrial capacity, which Germany clearly could not do, or finding tactical innovations that rendered their material advantages irrelevant, which seemed increasingly unlikely as American forces deployed their industrial output in North Africa.
The evening of June 3rd brought reduced American activity as engineering operations concluded and the airbase transitioned to routine flight operations, but even in this reduced tempo, Steiner observed efficiency that impressed him. Ground crew performed aircraft maintenance with systematic precision, fuel trucks moved on established schedules without apparent confusion, guard rotations changed with military formality, and the entire complex functioned with coordination that suggested thorough training and clear procedures. The Americans had established portable lighting for night operations, positioning generator-powered floodlights that would allow continued aircraft movements after dark, capability that German air bases in North Africa struggled to maintain due to electrical generation limitations. And watching these lights illuminate the newly constructed airfield, Steiner had reflected on the resource disparities that characterized this theater, that Americans could deploy portable electrical generation capacity equivalent to small city power systems to support single air bases, while German forces operated with electrical infrastructure that barely supported essential communications and medical facilities. Obergefreiter Ludwig Brandt from the Signals Company had arrived at sunset, establishing a listening post to monitor American radio communications, and within the first hour of monitoring, he had identified the operational patterns that confirmed the airbase's functionality. Aircraft receiving landing instructions in clear protocols, ground crew coordinating fuel deliveries through established procedures, maintenance personnel reporting status updates on scheduled intervals, all conducted through radio networks that operated without the interruptions and failures that plagued German communications in North Africa. Brandt had extensive signals intelligence experience, and he noted that American radio discipline exceeded British standards, that their communications followed structured formats that facilitated rapid information exchange, that their operators transmitted with clarity and precision rather than the casual informality that characterized German tactical networks, and these observations suggested that American military effectiveness extended beyond equipment superiority to include superior training, procedures, and organizational culture, that their advantages were systemic rather than limited to specific technological capabilities. The night of June 3rd to 4th brought confirmation of the airbase's operational integration with American air forces as bombers arrived to rearm and refuel before conducting night missions against Axis supply lines.
their presence demonstrating that the newly constructed airfield had immediately entered the combat sortie cycle, that American planners had synchronized construction timelines with operational requirements so that completed airbases became available precisely when needed for scheduled missions. Steiner had observed these night operations through darkness vision binoculars, watching bombers taxi, load ordnance, and depart from missions that would interdict German supply convoys, the direct causal chain from airfield construction to German logistics problems visible in real-time tactical reports. And he had understood that American engineering speed created operational tempo advantages that compounded daily, that each 72-hour construction cycle added new airfield capability that expanded American reach while constraining German operations, and that the cumulative effect of simultaneous construction projects across the theater would create air power superiority impossible to challenge with limited Luftwaffe resources. Hauptmann Weber had returned to the observation post before dawn on June 4th, bringing orders for withdrawal as German forces consolidated defensive positions further west. And the two men had taken final observations of the American airbase that had materialized in 72 hours, noting additional improvements already underway. Expanded dispersal areas to accommodate more aircraft, construction of permanent buildings to replace tents, installation of additional fuel storage capacity, all suggesting that the Americans viewed this airfield not as temporary forward base, but as permanent infrastructure that would support sustained operations throughout the campaign. Weber had shared intelligence summaries indicating that American engineering battalions were arriving in theater in increasing numbers, that the construction projects they had observed represented only initial deployments, that American plans apparently included comprehensive airbase networks that would support massive air operations against Axis forces. And his briefing had concluded with the assessment that German tactical excellence could no longer compensate for material disadvantages of this magnitude, that unless German production dramatically expanded or Allied logistics were successfully interdicted, the Afrika Korps faced inevitable defeat against opponents who could manifest military infrastructure through industrial processes that transcended traditional engineering limitations. The withdrawal from the observation post on June 4th required a circuitous route through wadis and broken terrain to avoid American air patrols that now operated from the newly constructed airfield. And during this movement, Steiner had experienced firsthand the operational consequences of American engineering speed. German forces that had moved freely across open desert days earlier now required concealment and indirect routes, their mobility constrained by American air power enabled by infrastructure that had not existed 72 hours prior. The march back to divisional positions took 14 hours, covering 60 kilometers, triple the time required for equivalent distance before American air bases proliferated across the theater. And every German soldier understood, without explicit discussion, that their operational freedom was evaporating daily as American engineers manifest airfields faster than German forces could adapt their tactics. Feldwebel Ernst Zimmermann from the signals platoon had monitored radio traffic during the withdrawal and reported 23 separate instances of American aircraft engaging German vehicle movements, strafing attacks on supply convoys and reconnaissance elements that would have operated without air threat just days earlier. The direct causal relationship between airfield construction and German casualties visible in real-time tactical reports.
Divisional headquarters occupied a dispersed position in a limestone quarry 30 kilometers southwest of Tobruk, the natural overhead protection offering concealment from the American air reconnaissance that had become omnipresent following the rapid airbase expansion. And returning to this position, Steiner had encountered dozens of other reconnaissance personnel who had observed similar American construction projects at locations across Cyrenaica. The reports describing identical equipment, identical timelines, identical outcomes, confirming that what he had witnessed represented standard American capability rather than exceptional effort. Lieutenant Hans Decker from the 3rd Reconnaissance Company had observed airfield construction near Martuba, and his description matched Steiner's observations precisely. 72-hour timeline, massive equipment deployment, pierced steel planking creating instant runway surfaces, integrated defensive perimeters established simultaneously with construction, and his conclusion echoed Steiner's assessment that German forces faced engineering capacity that fundamentally altered campaign dynamics.
that mobility advantages built through 2 years of desert warfare experience were being negated by American ability to project air power from rapidly constructed forward bases. The intelligence briefing on June 5th had assembled reconnaissance personnel from across the division. Oberstleutnant Wilhelm Hartmann from intelligence staff presented consolidated findings that painted a comprehensive picture of American engineering deployment. 12 confirmed airfield construction projects completed or underway within the division's operational area, estimated 6,000 American engineering personnel assigned to aviation construction missions, equipment inventories that exceeded German heavy equipment holdings for the entire theater, and, most significantly, construction timelines that allowed American air forces to establish operational bases faster than German ground forces could maneuver to interdict them. Hartmann had displayed captured American technical manuals that documented standardized construction procedures, revealing that American engineering battalions followed detailed specifications that eliminated variability, that any qualified battalion could build identical airfields anywhere given appropriate equipment and materials, that their construction capability derived not from exceptional individual expertise, but from systematic industrial processes that treated air-based construction as manufacturing problem rather than engineering challenge. The technical manuals themselves had fascinated Steiner, who examined them during breaks in the briefing, noting the comprehensive detail that covered every construction phase: site survey procedures with specific measurement requirements, grading specifications with exact tolerances, drainage calculations with standardized formulas, materials lists with part numbers and quantities, timeline charts showing expected completion rates for each task, quality control checklists ensuring consistent standards, and, perhaps most remarkably, troubleshooting guides addressing common problems with documented solutions, suggesting that American engineering doctrine anticipated difficulties and provided systematic responses rather than relying on improvisation. These manuals represented industrial thinking applied to military operations, treating air-based construction as a repeatable process that could be taught, standardized, and optimized, fundamentally different from German engineering approaches that emphasized adaptability and individual expertise over standardized procedures. And Steiner had recognized that American systematic methodology probably produced slower individual decision-making but faster overall execution through elimination of variability and uncertainty. Hauptmann Weber had presented detailed analysis of the equipment capabilities observed during the reconnaissance mission, noting that American bulldozers displaced approximately 3 times the earth volume per hour compared to German equivalents, that their scrapers combined loading and transport functions that required separate equipment in German operations, that their graders achieved surface specifications in single passes that required multiple passes with German machinery, and that all this equipment demonstrated reliability that allowed continuous operation without the frequent mechanical failures that characterized German vehicles in desert conditions. Weber had obtained maintenance records from a captured American supply dump, and these documents revealed preventative maintenance schedules that exceeded German practices, showing that Americans performed routine servicing at intervals designed to prevent failures rather than responding to breakdowns, that their logistics system delivered spare parts before components failed rather than after, and that their entire maintenance philosophy emphasized prevention over repair. And these systematic approaches contributed to the equipment reliability that enabled rapid construction timelines. The fuel consumption figures had particularly impressed the German intelligence staff. American engineering battalions consumed more fuel in 3 days of airfield construction than a German panzer regiment consumed in a week of combat operations. Yet this fuel appeared readily available without the supply constraints that plagued German operations, suggesting logistics capacity that could sustain consumption rates impossible for Axis forces. Oberstleutnant Hartmann had calculated that supporting a single American aviation engineer battalion required fuel deliveries equivalent to supplying an entire German division, yet Americans operated multiple such battalions simultaneously across the theater without apparent logistic strain, demonstrating either fuel abundance that defied German comprehension or logistics efficiency that delivered resources with effectiveness far exceeding German capabilities, probably both, factors combining to enable construction operations that seem to ignore normal supply limitations. Obergefreiter Paul Richter from the 8th Machine Gun Battalion had captured an American engineer during a patrol action near Derna, and this prisoner had provided insights that complemented the technical observations, explaining that American aviation engineer battalions trained for 6 months before deployment specifically on airfield construction techniques, that they practiced complete airbase construction at training facilities in the United States before arriving in theater, and their rapid timelines reflected extensive rehearsal rather than improvisation under pressure, that what German observers interpreted as exceptional effort represented routine American training standards. The prisoner, a corporal from Iowa named Robert Thompson, had described the training process with casual matter-of-factness that highlighted the systematic nature of American preparation. His battalion had built 7 complete practice airfields during training, each construction cycle identifying inefficiencies and refining procedures, creating experienced teams that could execute complex operations through practiced coordination rather than requiring detailed supervision. And Thompson had expressed surprise that German forces found 72-hour construction timelines impressive, noting that his battalion considered 3 days adequate but not exceptional, that some units completed functional airfields in 48 hours under optimal conditions.
The prisoner interrogation had revealed other significant details about American engineering doctrine. Aviation engineer battalions received priority equipment allocation comparable to armored units. Their personnel were selected from candidates with construction experience in civilian life. Their officers typically held engineering degrees from American universities. Their logistics support included dedicated supply battalions that provided materials and fuel without competing with combat units for resources, and their organizational structure emphasized horizontal coordination that allowed rapid decision-making without requiring approval through multiple command levels. Thompson had explained that his company commander possessed authority to modify construction plans based on site conditions without consulting battalion headquarters, that American doctrine trusted junior officers to make tactical decisions within strategic framework, contrasting sharply with German centralized command that required senior approval for significant deviations from established plans. And this decentralized approach probably contributed to American speed by eliminating delays inherent in hierarchical decision-making. The strategic implications had dominated discussions among German officers throughout early June, with growing recognition that American engineering capability created compounding advantages that would accelerate over time. Each completed airfield extended American air reach, enabling deeper interdiction of German supply lines, which reduced German fuel availability, which limited German mobility, which reduced ability to interdict new airfield construction, creating a self-reinforcing cycle where American advantages expanded while German capabilities contracted. Hauptmann Weber had articulated this dynamic during evening discussions at the officers' mess, noting that Rommel's tactical brilliance had achieved remarkable results against material disadvantages, but that American engineering speed had introduced a new variable that tactical innovation could not overcome, that building airbases faster than armies could advance fundamentally altered operational calculus in ways that favored the side with superior industrial capacity, which clearly meant the Americans and British rather than the Axis forces whose industrial base could not match Allied production even without considering the vast distances separating German factories from North African battlefields. The comparison with German engineering capabilities had become unavoidable during mid-June as the 15th Panzer Division attempted to construct a forward airstrip to support limited Luftwaffe operations, and this project had illuminated the capability gaps through direct contrast. German engineers required 2 weeks to grade a 1,200-meter runway using limited heavy equipment supplemented by extensive manual labor. The construction timeline extended by equipment breakdowns that consumed days in repairs, by fuel shortages that halted operations pending resupply, by organizational inefficiencies that resulted in work crews waiting for materials or equipment, and ultimately producing a runway surface inferior to American standards, usable only by small aircraft in good weather conditions, lacking the all-weather capability that American pierced steel planking provided. Steiner had observed portions of this construction effort, and the contrast with American operations had been absolute.
Where Americans deployed overwhelming equipment abundance that eliminated labor bottlenecks, Germans improvised with insufficient machinery supplemented by soldier labor. Where Americans worked systematic schedules that maximized equipment utilization, Germans experienced frequent delays as limited equipment moved between tasks. Where Americans achieved precise specifications through mechanical control, Germans accepted rougher standards that reflected manual construction limitations. Lieutenant Friedrich Becker from the engineering company had privately expressed frustration that German engineering doctrine emphasized tactical flexibility and improvisation, valuable qualities in many contexts, but less relevant for airfield construction that benefited from standardization and industrial methods. That German engineers were trained to adapt to varied circumstances with limited resources, making them excellent problem solvers but less effective at systematic large-scale construction that Americans approach as manufacturing process rather than engineering challenge. Becker had studied civil engineering at Stuttgart before the war, and he recognized that American methods reflected civilian construction industry practices scaled to military requirements. That their equipment, procedures, and organizational structures derived from industrial construction experience applied to military context, whereas German military engineering remained distinct from civilian practices, emphasizing military-specific solutions that often ignored relevant civilian innovations. And this isolation from civilian industrial methods probably contributed to German disadvantages in construction speed and efficiency. The psychological impact of witnessing American engineering capability had affected German morale in ways that transcended tactical concerns, creating fundamental doubts about German prospects in a war against opponents who could manifest military infrastructure through industrial processes that seemed almost magical in their speed and effectiveness. Feldwebel Otto Hartmann from the infantry regiment had observed during mess conversations that German soldiers increasingly questioned official propaganda about American weakness and incompetence, that direct observation of American capabilities contradicted everything they had been told about democratic society's inability to wage effective modern warfare, that watching American engineers build airfields in 3 days destroyed beliefs about German technological superiority that had sustained confidence through earlier defeats. And these psychological effects probably damaged German combat effectiveness more significantly than the tactical advantages Americans gained from rapid airbase expansion, because soldiers fighting without confidence in ultimate victory performed differently than soldiers believing in inevitable triumph. The mail from home during June and July 1942 introduced additional cognitive dissonance as German soldiers in North Africa read letters describing bombing raids on German cities, food shortages requiring severe rationing, factory workers laboring 12-hour shifts to meet production quotas, civilian suffering that contrasted sharply with the material abundance Americans demonstrated in theater. And Steiner had begun to recognize the fundamental asymmetry. Germany mobilized its entire society for total war, straining every resource to sustain military operations, while Americans apparently waged war with surplus capacity, deploying construction equipment and supplies with such abundance that they could build airfields in 3 days, while maintaining civilian production that exceeded German wartime output. His wife's letters from Hamburg described queuing for bread rations, factories damaged by RAF bombing, neighbors killed in air raids. And reading these descriptions while observing American engineering battalions operating with equipment abundance that suggested unlimited resources created psychological tensions that no military training addressed, forcing recognition that Germany fought opponents whose industrial capacity rendered German material sacrifices almost meaningless in comparative terms.
The tactical adaptations that German forces implemented in response to American airbase expansion had demonstrated the operational constraints created by engineering speed, increased emphasis on night movements to avoid air attack, dispersal of vehicle concentrations to minimize strafing damage, abandonment of daylight supply convoys in favor of nocturnal logistics, camouflage discipline that consumed time and resources, all defensive measures that reduced German operational tempo while Americans maintained aggressive posture enabled by air superiority. Hauptmann-Weber had noted during tactical discussions that German forces were increasingly reacting to American capabilities rather than implementing independent operational plans.
That initiative had shifted to opponents who could create supporting infrastructure faster than German forces could maneuver, that Rommel's mobile warfare doctrine required freedom of movement that American air power was systematically eliminating, and without dramatic changes in relative capabilities, the Afrika Korps would find itself confined to increasingly defensive posture, waiting for inevitable Allied offensive that would exploit both material superiority and positional advantages. The American construction of coastal road networks to support logistics had provided additional evidence of engineering capability that exceeded German equivalents, as American engineering battalions simultaneously built airfields and improved road infrastructure, creating integrated transportation systems that enhanced their logistics efficiency, while German forces operated on the same inadequate road network that had constrained operations since 1940. Steiner had observed American road construction near Benghazi during a reconnaissance patrol in July, watching bulldozers grade new routes through terrain that German forces had considered impassable to supply vehicles, and the speed of this construction matched the airfield timelines, American engineers completing kilometers of improved roadway daily using the same overwhelming equipment abundance and systematic methods that characterized their airbase projects. These roads were not temporary tracks, but properly engineered routes with drainage culverts, reinforced surfaces, and grades that allowed heavy vehicle traffic in all weather conditions, infrastructure that would support military operations throughout the campaign and remain valuable for civilian use afterward. And their construction revealed American thinking that extended beyond immediate tactical needs to consider longer-term strategic requirements. The intelligence reports from German forces across the Mediterranean theater had confirmed that American engineering capability observed in North Africa represented global deployment, with similar construction timelines reported from Sicily, southern Italy, and the Pacific Islands, suggesting that Americans had developed standardized engineering methods that functioned effectively across diverse environments, that their industrial approach to military construction produced consistent results regardless of specific terrain or climate conditions, that they had solved the problem of rapid military infrastructure development through systematic procedures rather than relying on exceptional circumstances or extraordinary efforts. Oberstleutnant Hartmann had shared captured British intelligence assessments that described American aviation engineer battalions as game-changing capabilities that fundamentally altered operational planning, that British commanders now assumed airbase availability within 72 hours of securing territory, that this assumption enabled air operation planning impossible under previous construction timelines, and these British perspectives confirmed German observations while adding Allied strategic context that explained how engineering speed enabled operational concepts that would have been impractical with traditional construction timeframes. The summer of 1942 brought increasing American air presence enabled by the airbase network that continued expanding despite German efforts at interdiction, and Steiner's reconnaissance duties evolved to emphasize monitoring American construction activities rather than traditional enemy force location missions, reflecting command recognition that American engineering capability represented strategic threat comparable to combat forces, that understanding their construction methods and timelines provided intelligence value exceeding tactical unit positions. The reconnaissance reports had accumulated into comprehensive assessment of American engineering doctrine, revealing patterns that enabled predictions about future construction locations and timelines, and this intelligence had proven valuable for German operational planning, even though it could not prevent American construction or neutralize its effects, because understanding opponent capabilities remained essential even when countering those capabilities exceeded available German resources. Major Werner Steinhoff from Division Intelligence had conducted detailed analysis of the equipment that enabled American construction speed, obtaining specifications through various intelligence sources, including captured documents, prisoner interrogations, and aerial reconnaissance photographs, and his findings had quantified the industrial gap. A single American aviation engineer battalion possessed heavy equipment equivalent to the entire German engineering allocation for North Africa, their bulldozers alone representing manufacturing output that exceeded German production of similar equipment by factors of 10 or more, and their logistics system delivered this equipment to theater with reliability that German forces never achieved even for combat vehicles. Steiner had calculated that replicating American engineering capability would require German industry to increase heavy equipment production by orders of magnitude while simultaneously developing logistics infrastructure to deliver and maintain that equipment in overseas theaters, investments that Germany could not make given existing industrial commitments to tank, aircraft, and ammunition production. And his conclusion had been stark. Germany could not match American engineering capability through industrial expansion, meaning that American advantages in construction speed would persist and probably expand throughout the war. The philosophical discussions among German officers during evening hours had increasingly focused on the implications of American material superiority, with growing recognition that ideological commitment and tactical skill could not overcome industrial capacity differences of the magnitude Americans demonstrated, that modern warfare favored nations with extensive manufacturing capability over nations with superior military traditions, that the Industrial Revolution's logic had finally reached military competition where production capacity determined outcomes more decisively than warrior spirit or tactical innovation. Hauptmann Weber had articulated this recognition most directly during a conversation in late July, stating that Germany had entered a war it could not win through military excellence alone, that defeating opponents who could manufacture bulldozers faster than Germany produced tanks required either industrial mobilization beyond Germany capacity or opponent logistics collapse that showed no signs of occurring, and that professional officers had obligation to recognize these realities rather than sustaining hopeful delusions that served political requirements but ignored military facts.
Obergefreiter Hans Müller from the Artillery Regiment had shared perspective from enlisted ranks, noting that ordinary soldiers understood German material disadvantages through direct observation without requiring intelligence briefings, that watching American aircraft dominate skies unopposed by Luftwaffe, observing American vehicles operating reliably while German trucks required constant maintenance, experiencing American artillery bombardments that exceeded German capabilities in duration and intensity. All these daily experiences taught lessons about relative industrial capacity more effectively than any formal instruction, and soldiers drew their own conclusions about war's likely outcome based on what they witnessed rather than what propaganda claimed. Müller had served since Poland, and he described the psychological evolution from confidence in German superiority through various stages of doubt to current resignation that Germany fought opponents whose material advantages could not be overcome through courage or skill, that survival rather than victory had become the realistic objective for individual soldiers who understood intellectually that the war was lost even if official doctrine prohibited expressing such recognition. The medical reports from division aid stations had documented stress-related illnesses increasing among German personnel during summer 1942, physicians attributing some portion of these medical problems to psychological strain of fighting against overwhelming material odds, of maintaining discipline and effort while recognizing that individual sacrifice could not alter strategic outcomes, of reconciling personal duty with intellectual understanding that Germany's cause was hopeless. Oberarzt Heinrich Weber, the division medical officer, had discussed these issues with Steiner during a chance encounter at headquarters, explaining that human psychology struggled with cognitive dissonance between duty and futility, that soldiers functioned most effectively when believing their efforts served meaningful purposes, and that growing recognition of inevitable defeat created mental health challenges that no medical treatment addressed, because the underlying cause was strategic reality rather than individual pathology. Weber had noted that German soldiers continued performing their duties with professional competence, despite psychological understanding of war's trajectory, that military discipline and unit cohesion sustained effective performance even among personnel who privately doubted German victory,
but that this psychological burden accumulated over time and would eventually manifest in ways that reduced combat effectiveness regardless of tactical competence. The capture of additional American engineering personnel during August 1942 had provided more detailed insights into American military culture that explained their engineering success, revealing organizational approaches and cultural values that differed fundamentally from German military traditions. Sergeant Michael O'Connor from the 809th Aviation Engineer Battalion, captured during a raid on a construction site near Tobruk, had described training and organizational culture that emphasized initiative, problem-solving, and horizontal communication rather than rigid hierarchy. That American engineer battalions encouraged junior personnel to identify efficiency improvements and modify procedures based on field experience. That their doctrine valued results over strict adherence to established methods. And this flexibility within a systematic framework probably contributed to their construction speed by eliminating delays associated with hierarchical approval processes, while maintaining standardization through common training and shared objectives. O'Connor had explained that American engineer battalions included personnel from diverse civilian backgrounds, construction workers, equipment operators, surveyors, mechanics, all bringing professional expertise that translated directly to military engineering tasks, whereas German military engineering typically recruited from general military population and trained soldiers in engineering skills, rather than recruiting civilian engineers into military service. This American approach meant their engineering battalions possessed deeper technical expertise and required less training to achieve operational proficiency. That they could deploy to combat theaters with confidence, their personnel understood construction fundamentals from civilian experience rather than learning everything through military instruction. And this civilian expertise probably enhanced their construction speed by bringing proven methods from American construction industry that had developed efficient techniques through commercial competition, techniques that Germans would need to rediscover through military trial and error. The observation of American personnel management during August had revealed additional organizational differences. American engineer battalions rotated personnel through different tasks to maintain skills and prevent boredom, scheduled regular rest periods to prevent fatigue, provided recreational facilities even in forward areas, emphasized morale maintenance as leadership responsibility, and generally treated soldiers as valuable resources requiring care rather than expendable assets to be utilized until exhausted. Lieutenant Becker had noted that American approaches reflected industrial management principles applied to military organizations, that their personnel policies resembled factory workforce management more than traditional military discipline, and that these civilian-influenced methods probably contributed to sustained productivity by maintaining worker morale and preventing burnout, whereas German emphasis on duty and sacrifice could produce short-term intensity but probably reduced long-term effectiveness through accumulated exhaustion and declining morale. The strategic situation by September 1942 had deteriorated significantly for Axis forces in North Africa, with American and British forces preparing major offensive operations supported by air superiority, enabled by the extensive air base network constructed during summer months. And German intelligence estimates projected that Allied forces would achieve decisive material advantages by late autumn, as additional American units completed deployment and training. Steiner's reconnaissance missions during September had confirmed continued American construction activity, with new air bases established to support the anticipated offensive, and existing bases expanded to accommodate increased aircraft numbers. And the systematic nature of this construction effort revealed long-term planning that anticipated extended campaigns rather than seeking immediate tactical advantages. That Americans were building infrastructure to support sustained operations over months or years rather than temporary positions for specific battles.
The final reconnaissance mission to observe American engineering operations occurred in October 1942 as Steiner and a small team infiltrated forward to observe construction activities near El Alamein, and this mission had provided opportunity to witness the culmination of American engineering deployment with major airbase complex under construction to support Montgomery's offensive. The scale exceeded anything Steiner had previously observed, with multiple aviation engineer battalions working simultaneously on interconnected air bases, support facilities, and logistics infrastructure, creating integrated air operations complex that would support hundreds of aircraft in sustained combat operations. The construction equipment visible from Steiner's observation position exceeded his ability to count accurately, dozens of bulldozers and scrapers working in coordinated patterns that suggested sophisticated project management. And watching this massive construction effort unfold with mechanical precision, Steiner had experienced final recognition that Germany faced opponents whose industrial capacity existed at fundamentally different scale than German equivalents, that tactical innovation could not overcome material disadvantages measured in orders of magnitude rather than incremental percentages. Hauptmann Weber had joined this final reconnaissance mission, wanting to observe American operations personally before the anticipated Allied offensive, and during the long hours observing construction activities, the two men had discussed implications that extended beyond North African campaign to encompass the entire war. Weber had articulated what both men understood, that American engineering capability observed in desert construction represented merely one application of industrial capacity that would eventually deploy across all warfare domains, that opponents who could build airfields in 3 days would inevitably develop similar systematic approaches to tank production, ammunition manufacturing, ship construction, that Germany faced enemies whose economies could sustain material output beyond German capacity to counter through efficiency or innovation, and that unless fundamental circumstances changed dramatically, German defeat was mathematically certain regardless of tactical outcomes in specific battles. The return journey from this final reconnaissance mission had occurred during the opening phase of the El Alamein offensive, with British and American forces attacking German positions, supported by overwhelming artillery and complete air superiority. And traveling through the battle area, Steiner had witnessed the operational manifestation of American engineering capability, aircraft operating from the newly constructed air bases, providing continuous close air support, destroying German armor, and disrupting defensive positions. The tactical impact of construction activities observed months earlier, now visible in combat operations that systematically dismantled German defensive positions. The defeat at El Alamein marked the turning point for Axis forces in North Africa, but for Steiner, the defeat had been apparent since June when he first witnessed American engineers building airfields in 3 days, understanding then that opponents with such capability would eventually concentrate sufficient forces to achieve breakthrough regardless of German tactical skill. Obergefreiter Klaus Steiner survived the North African campaign, retreating with German forces through Libya and Tunisia before evacuating to Sicily in May 1943, and throughout the final months of the campaign he continued reconnaissance duties that provided opportunities to observe American engineering operations, watching as they built ports, roads, airfields, supply depots, creating comprehensive infrastructure that supported Allied advance, while German forces operated with deteriorating logistics and diminishing resources. The systematic nature of American engineering, observed over 12 months from June 1942 through May 1943, had taught Steiner lessons about modern warfare that contradicted his training and challenged assumptions that had seemed self-evident before witnessing American industrial capacity deployed in combat theater. That victory required not just tactical brilliance, but sufficient industrial base to sustain operations. That modern warfare favored nations with extensive manufacturing capability over nations with superior military traditions or tactical innovation. That engineering and logistics determined strategic outcomes more decisively than battlefield courage or operational innovation. The post-war years brought opportunities for Steiner to reflect on his North African experiences, and in conversations with fellow veterans, he consistently emphasized the American engineering capabilities as the most significant factor in German defeat, more consequential than British tactical competence or American numerical advantages, because engineering speed enabled operational tempo that German forces could not match, creating compounding advantages that eventually made German tactical excellence irrelevant to strategic outcomes. The image that remained most vivid in his memory was not combat action or dramatic tactical moments, but rather that June morning in 1942 when he stood at his observation post watching American engineers complete an airfield in 72 hours, understanding in that moment that Germany fought opponents whose industrial capacity existed at different scale than German equivalents, that tactical innovation could not overcome material disadvantages measured in orders of magnitude, that the war's outcome was essentially determined by relative industrial capacity, regardless of battlefield performance. The lessons Steiner drew from observing American engineering capability extended beyond military analysis to encompass broader understanding about industrial societies and modern warfare, that nations with extensive manufacturing base possessed decisive advantages in protracted conflicts, that systematic approaches to military engineering produced better results than reliance on individual brilliance, that treating military construction as industrial process rather than engineering challenge enabled speed impossible through traditional methods, that organizational culture emphasizing initiative and problem-solving enhanced effectiveness even within standardized frameworks, and most fundamentally, that modern warfare required industrial capacity to sustain operations over time, that tactical excellence provided temporary advantages, but industrial superiority determined ultimate outcomes. These lessons, purchased through direct observation of American capability during 12 months in North Africa, informed Steiner's understanding that Germany had entered a war it lacked industrial capacity to win, that American engineering speed observed in desert airfield construction represented merely surface manifestation of industrial advantages that permeated all aspects of military competition, and that future conflicts would increasingly favor nations with superior manufacturing capability over nations with superior military traditions or tactical innovation.
The specific memory of watching American engineers build an airfield in 72 hours remained a paradigmatic example of American industrial approach to warfare, encapsulating, in single observable event, the systematic methods, equipment abundance, organizational efficiency, and relentless execution that characterized American military operations across all domains. And Steiner carried this memory as cautionary lesson about underestimating opponents, about recognizing when tactical competence could not overcome material disadvantages, about understanding that modern industrial warfare favored nations with manufacturing capacity over nations with martial traditions. The young German soldier who had stood frozen in disbelief that June morning in 1942, watching impossibly rapid construction unfold before him, had learned through direct observation what no training could teach, that wars between industrial nations were won in factories before being decided on battlefields, that engineering capability represented strategic weapon comparable to combat forces, and that opponents who could manifest military infrastructure through industrial processes possessed advantages that tactical brilliance could not overcome, lessons that remained relevant long after the specific circumstances of North African campaign faded into history. Universal principles about industrial warfare that transcended particular battles or campaigns to illuminate fundamental dynamics of modern military competition. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.